Okay, so dear students, let us see the example on curvilinear motion. Okay, so the motion of a particle in xy plane is defined as x is equals to t square plus 8t plus 4 and y is equals to t cube plus 3t square plus 8t plus 4, where x and y are in meters, that means displacement, and t is in seconds, time. Okay, find the resultant velocity and acceleration at t is equals to 0 and at t is equals to 2 seconds. So what we are given, that displacements in terms of time are given. X is equals to this t square plus 8t and this y is equals to t cube plus 3t square, like that. Okay, so x is equals to t square plus 8t plus 4. So vx, obviously differentiation of this, 2t plus 8, and ax, so differentiation of this again, it's 2. Now y, t cube plus 3t square plus 8t plus 4, as simply as it is given. Okay, vy, differentiation of this, 3t square plus 6t plus 8, and ay 60 plus 6, so just differentiation. Now at time t is equals to 0, put this value t is equals to 0 in this vx equation, you get vx is equals to 8 and vy is equals to 8. Okay, but we know total velocity is vx square plus vy square, so it is 11.3 meter per second. Okay, and so the angle alpha, tan inverse of vy upon vx, it is 45 degree. Okay, now acceleration at time t is equals to 2, sorry, acceleration at acceleration there at time t is equals to 0. So ax is equals to 2 as given here, and ay is equals to 6 as it is given here. Okay, when you put t is equals to 0, this ay is equals to 6. So a is equals to square root of ax square plus ay square. So you get a as 6.32 meter per second and angle beta as tan inverse of ay upon ax as 71.5 degrees. This is for t is equals to 0. Next thing is to find out what are the values at t is equals to 2. So for t is equals to 2, vx is equals to 12, vy is equals to 32. Simply we are putting the value of t is equals to 2 in the vx and vy equation. But v is equals to square root of vx square plus vy square, so we get it as 34.1, okay, meter per second. And alpha, tan inverse of vy upon vx, it is 69.4 degrees. Next ax, it is 2, ay it is 18. See, ax as it is 2 and ay for t is equals to 2, 6 into 2 plus 6, 12 plus 6, it's 18, so ay is equals to 18. So a is equals to square root of ax square plus ay square, we know this stuff, 18.11 meter per second square. Beta, tan inverse of ay upon ax, and this comes out to be 83.6 degrees. Okay, next question. Actually I want to cover more and more questions in one video now. Okay, next, a plane travels along parabolic path when it is at point A. So this is it, x-axis, y-axis, this dotted line indicates the path of uh, plane. Okay, so when it is at point A, this point A is at 10 kilometer high and 5 kilometer from origin. Okay, and equation of motion y is equals to 0.4 x square, this much is given. Okay, so when a plane travels along a parabolic path, when it is at a point A, it has a speed of 200 meters per second and it is increasing at a rate of 0.8 meter per second square. So acceleration is given and velocity is given. Determine the magnitude of acceleration of plane when it is at A. Okay, now you will see, so what is this acceleration is given and still determine the magnitude of acceleration is being asked. So what is it? Simply this is one type of acceleration and this is total acceleration being asked. So which type of acceleration it is? Tangential. Okay, so this tangential acceleration is given and we are being asked the total acceleration. Okay, so see how you are going to solve this. So at a 80 tangential component of acceleration, it is 0.8 meter per second square as it is. Okay, so velocity 200 meter per second as it is given, 200 meter per second. Okay, now to find acceleration, a is equals to square root of a n square plus 80 square. Okay, so we have 80 but we don't have a n. Now an is given by the formula v square upon rho a. V is velocity and rho a radius of curvature at a. Okay, but we have velocity, we don't have rho a. Now the formula for rho a. Okay, and for that we need the equation of the path. So we are given it's y is equals to 0.4 x square, right? So 0.4 x square, so dy by dx is equals to 0.8 x. Okay, so dy by dx at x is equals to 5, this is 4, and d2y by dx squared is 0.8. Okay, now the formula for rho a is this: 1 plus dy by dx bracket square whole raised to power 3 by 2, this whole divided by d2y by dx square. Okay, I want you to remember this formula thoroughly. Okay, rho a, radius of curvature at point A, is equals to 1 plus dy by dx bracket square whole raised to power 3 by 2 whole divided by d2y by dx square. Okay, so we have already found out those values, dy by dx and d2y by dx square. So 1 plus 4 square bracket to the power 3 by 2 divided by 0.8, it comes out to be 87.61 kilometer. So we have got an now, v square by rho a as this 0.457 meter per second square. So acceleration a is equals to, in the formula, square root of an square plus 80 square, it is 0.921 meter per second square. So a is 0.921 meter per second square, and that was asked. Determine the magnitude of acceleration at the of the plane where it is at a. Okay, thank you.